right-eye goes up and down because they've got quite a lot of right-eye change. These cars where the front doesn't really move very much, it's a bit less. But what tends to happen is that there's a sweet spot where you can get it to about within perhaps a mil to a mil and a half, and if you're going to have a discrepancy and that you can't fix completely, you want to make it so that it toes in rather than toes out under mil. And the way you change that is by changing the, I'll go through this before, changing the spaces in here and getting this point from a geometry point of view to move in relation to this one, so that as the wheel goes up and down, it's not doing this. Okay. Any questions about that?
So how do you set it up and change it?
Okay.
How do you measure your bump stir?
I'll go over that a little bit in. No, I didn't write that down in there. Yes, I did. We'll go over that just in this other sheet. We'll just gloss over this bit for a start. Okay, spring rates. What sort of spring rates? What's it measured in?
Stiffer on the front and softer on the rear. It depends.
Not necessarily. It depends on a couple of things. It depends on what you want to use, and it also depends on these little rockery things here. You can see this front one here is about probably 1.4 to 1. So for every 1 millimetre that bit moves, this would move 1.4 millimetres. So the ratio of that rocker will depend on the spring rate that you use. And various cars have got different spring rates. Spectrums in particular tend to have a very linear rocker, and that's where this point here is right up here, so that it tends to not increase.
Sorry, what do you mean by a spring rate?
Well, I was just going to go through that. The spring rate is the amount of pressure that it takes to move that spring 1 inch. So if you've got a 250 pound spring, we've got a tester upstairs, we'll go and have a quick look at that later. Got a 6-inch spring and you compress it 1 inch and it's a 250 pound spring, it should read 250 pounds at 1 inch. And if it doesn't, then it's either been weakened somehow, it's been overstressed, or it's just old and it's fatigued. And it's really important that they're a pair, because when you try to set the car up, if it's not a pair, trying to make some adjustments to compensate for it makes your life very difficult, and it does tend to be quite confusing. So my suggestion is that if you've got any springs that you're a little unsure about, just bring them in and we'll just test them. It takes 10 minutes.
So they have a limited life?
They do. It's just a piece of steel and it's twisting all the time, and eventually they'll just go weak. And generally they won't all both go the same. One will go before the other. So it's a good idea to keep good springs in the car. Spring preload and how it affects the car. Does anybody know what we're talking about here? Droop, a function of it. But this preload on the spring is the amount that this platform is wound up from where the spring is at its free length. So if you've got a 6-inch spring, it'll be 6 inches long, and if you wind that platform up and stop it at 6 inches, then that would be what we consider to be zero preload.
So it's not under any pressure.
It's not under any pressure at all when the shocks are fully extended. Now, most of the cars like this, and we're predominantly talking Spectrum, Van Diemen, Stealth, whatever. Most of them would have no droop in the front. In other words, if I come around here and go to lift this, even if somebody was sitting in it and I go to lift it up, it doesn't come up. The older cars are not like that, but there's a different reason for that. So that car there would be deemed to have zero droop, so it will only go down and come back up to the right eye. Now, to achieve that, you'll need to wind 3 or 4, maybe 5 turns onto that spring to enable the spring, which is not doing any work when it's not compressed, to take up the weight of the front of the car. So you just wind it up until the car stops lifting. and then that would be considered to be zero droop.
Can't take that for granted though, if you're just starting off with the car, you've got to go back and then start winding it in there.
What you would do when you're setting the car up is you would wind it on more than you want, so that it's topped out, so that it has no droop. And then once you've got all the rest of the setup sorted, then you'd back it off until you get to the droopy point, until it just starts to droop. And in most cases, you would wind on 1 or maybe 2 turns.
Why?
Just to be able to allow the spring to have control and to make sure that the car doesn't have any droop, so that it will go down, come up to that same point all the time. The problem you have is if you run the car with droop, as the shock warms up, it'll go up and it might have 5 mils of droop now. Halfway through the race it might have 8 or 10 or less, because things are changing dynamically. So we've always found that it's better to keep the car right up at top, what we would call topped out, and it does tend to give you more control over the rear of the car in the high speed corners as well.
That also makes it stiffer as well, does it? And stops the chassis roll at the same
Correct.
time?
Yep, it's not the only function of that, but it does stop some of that roll. Yep, yep.
You mentioned earlier some of the older cars need a little bit of droop.
Whether they need it, it's designed into them because they have just a shock absorber and they don't have a push rod and they don't have a rocker. So you basically are stuck with a shock that's X long and a spring that's X long, and to get the right height you just change the platform height. You can look at it on that car there. Change the platform height, and depending on where you're going to put it, you may have a situation where when you lift the car up, the suspension droops down like this and all the springs come loose. But you can't fix it because the function of the way the car's designed doesn't allow you to do what we're talking about here. Okay, so the springs are rated in pounds per square inch, and they generally got a notation on them on the outside, especially if you're buying ones like this, and they'll say 6 inch 225 by 3 by 3, or that's actually a 300 spring, 600 long, 6 inches long, 300 pound, and it's 2 1/4 inches inside. So the diameter is always taken on the inside. And the most common spring on these sorts of cars is a 2 1/4, not a 2 1/2, which you would use on the likes of a saloon car or things like that. Okay, we'll move on to corner weights. Everybody understand what we're talking about there? What about some of you new guys? Yeah. Okay, so anybody had a chair that cut an inch off the bottom of one leg? Same deal with your racing car. If it's not square in a plane this way and this way, then the weight of that wheel and the weight of that wheel won't be the same. And that one. They'll be different front to rear, but they need to be the same left to right. And in my opinion, within a kilo or 2 is acceptable. And if you did have a discrepancy just because of the way you've set the car up and you couldn't get it absolutely perfect, you would always try and make sure that the inside of the hairpin wheel is the one that's heavy. So if you've got a slightly odd spring and you can't deal with it, you might go, well, I don't really want that one to be heavy, I'll take that spring out and put it over there. So when you're hard braking into corners such as hairpins and things like that, the inside wheel is always the one that's going to lock up, and that's a reasonable way of trying to compensate for that if you need to. Right. Okay.
Great. Can I just ask a
Sure.
question? With the effective camber and caster, have you ever weighed the corner weights when you're on lock and seen what happens to those?
Yep. What do you think happens?
I'd say they change a hell of a lot.
They do. Which one gets heavier? If you're turning left, which one gets heavier?
I think your left one gets heavy.
If you're turning left?
Yeah.
Correct. Yeah. Yep, that's exactly. And that's a function of something which I haven't actually put in these notes because it's starting to get quite complicated. Is a thing called the scrub radius. And if you turn the wheel around like this, you can see this wheel's laying over this way, this wheel's laying over that way, and depending on whether there were any spaces on this wheel could be here, or it could be here, or even out here. Your car in particular has got a really nasty scrub radius, and the scrub radius is the distance from a line drawn between that point there and the bottom point, and where it touches the ground in relationship to the centre of the tyre. So if it was out here, these 2 points aren't going to move, but the centre of the tyre is going to be over here, and you'll end up with this really wide scrub radius. It'll do 2 things. The first thing it'll do is make the steering really heavy, really heavy to turn. But it will also make the car turn in like crazy in the very initial part of the turn, the first third of the corner. And then generally it'll go to custard after that if you've got too much scrub radius. The car will bite in really well, and then when you start to drive the car off the turn, all sorts of funny things can start to happen.
So that's a factor of the spaces you've got on your tyres as well, effectively.
Absolutely, it changes it. If you put 3/4 of an inch of spacer behind the wheel, between the hub and the wheel, that will give you an increased scrub radius, and it will improve the car in certain places, and it will make it worse in others. And that's part of that decision-making process as to where you're having trouble and whether you want to try it or you don't want to try it, and whether you want to go back or forwards. I mean, a lot of these things are pretty tried and true, and sometimes it's better to accept the fact that there's lots of people who have tried these things in the past, and there's other areas to try and improve on. I mean, your driving, your technique, your braking, and lots of other things to worry about. These cars, I mean, all the Van Diemen range, the Spectrums as well, any of the other cars, they're all pretty tried and true if you've got them set up the way they were built, or the way that the tradition is, I suppose, if you call it, that's the right word. I mean, we've got folders there, I don't know how many hundred thousands of miles of running these cars, and that information's all there. So, I mean, somebody coming along doesn't necessarily need to go and do 10,000 miles of testing just to figure out how much towing you want to run. So, quite good from that point of view. So, we've briefly touched on droop earlier. Does everybody understand what we're talking about?
What was that?
Droop.
Oh, yeah.
What's considered to be droop. So, we've already said we're going to have pretty much no droop at the front, or some margin between none and maybe a mil or two. What about the rear?
35.
Yeah. What would happen if you only had 10? What do you think?
Wouldn't lift.
Pardon?
A car wouldn't lift.
The car wouldn't lift? No. Yep. What do you think that would do?
You're not going to get as much weight over the front tyre, so your front braking's not going to be quite as good.
No, it wouldn't make any difference to the front, in my opinion. What it would do is that when you jump on the brake and the car starts to transfer some weight to the front, it would take all the weight off the back wheels. So it's a function of the weight coming off these wheels that would put some weight on the front. It would tend to make the car really skitty going into fast, hard braking corners. Okay. What's the function of increasing it though going to do? Perhaps if we had 50 or 60 millimetres. You'd end up with more roll, yeah, because it wouldn't be as stiff, yeah. Would we pick a bit of grip up perhaps? Maybe in the back. We'd pick some grip up in the rear. So there's a commonality between the amount of too much droop and not enough droop, and the window is somewhere, with most cars, in and around that 35, maybe as low as 30, up to 45 to 50. The 91 car, in my experience, if you can get a 91 car running with one of these really light rear anti-roll bars, something as light as that, something as light as that one, pass that one around, with a 275 spring in the rear of it, it'll come off those slow corners like no tomorrow. No inside wheel spinning up, none of that stuff, it'll just bolt off the turns. And if you reduce it down into the 30s, then you'll find that it'll be really good in the fast stuff, but it'll pick a wheel up off the corners on the inside. The diff will start to smoke up coming off those slower corners when the car's got a bit of roll, and because there's nothing on that wheel's off the ground. So it's a very, very slow, a very important trade-off between where you're going to do that. The other thing to remember is that the stiffer the car is in the rear, the more grip you'll have in the front. Does that make sense to everybody? So typically if you put more rear anti-roll bar on the car will turn in better, probably come off the turn better. And that's because you're picking grip up in the front. You're not really picking grip up in the front, you're just destroying the rear. And that's where the trade-off comes. You've only got X amount of grip, and you're either going to have it in the front or the back or some happy medium. And for those of you who have done quite a bit of driving, I think you'll all agree that a car that's balanced, even though it doesn't have the ultimate amount of grip, will always be faster and easier to drive than a car that's got massive amounts of rear grip but understeers like a pig, or they've got lots of front grip and oversteers like a pig. So that's where you've got to make your decisions as to where you trade.
You're mostly doing that with the rear roll bars, or anti-roll bars.
Front and rear, and to a very large extent with these cars, and certainly the 91 Van Diemen's in particular, the amount of preload in the rear spring and the size of the rear spring is pretty much what you tune the car on. They don't have an adjustable front bar generally. So high speed would be a little bit of droop adjustments in the front, and then the understeer or coming off the turns, power understeer as we would call it, you'd tune in the rear of the car, not the front. Does that sort of make sense to everybody?
So John, the notion behind zero droop at the front, is that simply to improve the front end under brake?
No, it's there to make the car turn in. The initial turn from straight ahead down to what I'd call down to the first third of the turn in. That's what it's there for, and it's a double function because the stiffer the front of the car is, the less oversteer the car will have on the exit. So if you had a car that was a bit taily and you had just a smidgen of droop in the front, and you crank 2 turns on the front of it, it'll improve the rear of the car because it's not rolling. And you might have heard people talking about roll oversteer, and that's the function of that. The car, you turn the car in and it goes like this, and because it hasn't got a diff in it, a proper diff in it, it just picks that wheel up and starts to spin that wheel. So you've only got half the amount of grip that you thought you had. Okay.
John, I'm still confused. With rear droop,
Yep.
what I don't get is too much too much? I mean, if you've had 100 millimetres of rear droop, you're never going to get the car jacking itself up 100 millimetres.
No.
So if 40 was good, is 60 really going to be slower? What's the downside of having too much droop?
It'll understeer. It's not stiff enough in the rear.
But why? Just because of weight transfers?
Yep. Yeah. The stiffness of the amount of grip you've got in the front is directly related to how stiff the car is in the rear. I know it sounds like double Dutch, but in practical terms, you've only got X amount of grip in the front, and if it's not enough, why isn't it enough? What do you reckon? Pardon?
Rear stuck.
Because the rear's stuck. So the balance of a car is just like a spring balance. Just like a weight balance. So if the weight of the car is 400 kilos and there's 50% of the grip on the front, there has to be 50% of the grip on the back. You put 80% of the grip on the front, you've only got 20% in the back. What's it going to do? It's going to be taily. So you've got to take some off the front, put some back in the rear, and get back to somewhere closer to 60-40, 55-45, something like that. I mean, these are just numbers to try and illustrate what I'm talking about. The balance of the car, as I said earlier, is the most important thing. The overall grip levels are not as important. So if you make the front of the, if you put really heavy springs in the car and you make the car turn in like crazy, the rear's not going to keep up. Unless you've got some magic way of making the rear catch up, but you've only got the same tyres and pretty much the same car, so that's sort of where that's at.
With my 92 Van Diemen, I've only got an anti-roll bar on the back.
Correct.
Do I have enough adjustment with that?
Yep. Yeah, absolutely. There is 3 different bars though, 3 different standard bars that you would use. I mean, the light one that I just passed around would be what you perhaps put on for the wet weather.
Yeah.
Very soft, very linear. The stiffer ones, the stiffer of the 2 would be what we consider to be the standard bar, and you'd use that in the dry when conditions are good. The other one is if the track was a bit marginal, wet dry, you'd probably go with the other one,
Okay.
slightly thinner at the top, so that it's soft at the top, but if it really needs to work, it goes stiff, and that will work really well in damp conditions.
So a rain roll bar would be better than just undoing it completely.
The convention is take the bar off,
Yeah.
but generally the cars understeer like crazy when you do that. I mean, everybody you talk to says take the bar off, take the bar off.
Yeah.
But these cars in particular, the long wheelbase Stealth, you'd never race one of these with the bar off it in the rain.
But everybody does.
Not everybody. So what I'm trying to get to is that these bars, I mean, the design of that anti-roll bar is not actually very good from an engineering point of view. They're quite highly stressed. They have a nasty habit of cracking, which is why we just made about 30 of them. But the cracks make a big difference to the way the car handles. If you've got a bar on there and the car's working really good, and then halfway through the day, it's a bit pushy, you can bet your boots it's got a cracked rear bar. And you can sort of repair them to a certain extent if you haven't got another one, but the big thing with them is to run them at the top and don't push them down too far. I mean, you certainly wouldn't run them down that far in the rear, because you just snap them off, and they get what we call twangy. They get stiff too quick. They ramp up too fast. It's better to run them long and change the bar for a softer one.
How much is a bar?